Alright, so here we go. So the second lesson we're going to do for class is, as it says here, classifying quadrilaterals, properties of parallelograms, special parallelograms, and trapezoids and kites. So lots of stuff involving quadrilaterals. So as I said before in class, probably the most important thing is you need to actually write down these definitions, and these definitions are really important. So if you have to hit pause and just copy these down, then go ahead and do that, or screenshot, or do whatever you can. Now, as far as our notes go, what we're really going to do is I'm just going to go through and maybe demonstrate some of these things just to hopefully make your life a little bit better. So let's start by just talking about what's a parallelogram. Well, a parallelogram is a quadrilateral. Well, let's back up. What's a quadrilateral? A quadrilateral, for the simplest definition, is basically it's a four-sided figure. And so a quadrilateral, there's lots of different types of quadrilaterals, and one of them being what we call a parallelogram. Well, let's see. A parallelogram is a specific one where opposite sides are parallel. So for instance, let's say I draw something like this. Okay, where opposite sides are parallel. Well, let's see. So that would mean, if we use the parallel symbols, that means this would be parallel to this, and then this would be parallel to this. There you go. Nothing more difficult than that. Okay, a parallelogram is simply a quadrilateral, so four sides, okay, whose opposite sides are parallel. Okay, simple. So let's move on. What's a rhombus? Well, rhombus is a parallelogram with four sides that are congruent. All right, well, let's start there for a second. It's a parallelogram, okay? So if I move this out of the way here for a second, so let's draw a different one. So it's a parallelogram. So that means opposite sides are, so the fact that it says a parallelogram, okay, right here, means that it has all the qualities of a parallelogram. So not only are the sides congruent, but they're parallel also. So it's going to be looking something like where all the sides are the same length, kind of like a square. Of course, it doesn't have to be right angles, that's why it's not necessarily a square. And then opposite sides are parallel. Okay, and there's a rhombus for you. Alright, so next question, or next one, is rectangle. Let's move this out of the way. So what's a rectangle? Well, a rectangle, again, is a parallelogram with four congruent, or pardon me, it's a parallelogram with four right angles. So sides don't have to be the same, okay, but it's a parallelogram, so therefore opposite sides are parallel. Okay, parallel, 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 parallel. But this time, the angles are right angles, and we use the right angle symbol for that. So all these are right angles. Okay, so a rectangle is just a parallelogram with four right angles. Easy enough. Let's keep going. Square. Well, a square is a parallelogram with four congruent sides and four right angles. So, as you can imagine, I know we all know what a square looks like. Opposite sides parallel. All the sides are the same length, and we have right angles. And there you go. So the question becomes, is a square a rectangle, or is a rectangle a square? Something for you to think about, and we can talk about that when we get into class. Alright, moving on. Okay, let's talk about kite. What's a kite? Well, a kite is a quadrilateral. Now notice this is the first time so far that we're not talking about parallelograms. So we're off the parallelogram train right now. It's just a quadrilateral, so four sides with two pairs of adjacent sides congruent and no opposite sides congruent. So as you can imagine, like that traditional kite-looking object, two adjacent meaning next to, sides that are congruent, and then another pair of adjacent. Okay, and so the definition says two adjacent, so that's adjacent and adjacent, and whose opposite sides are not congruent. Okay, and there you go, and there's a kite. Alright, almost done. Alright, trapezoid. Trapezoid, again, another quadrilateral, so not a parallelogram, quadrilateral with exactly one pair of parallel sides. Alright, so you could say parallel. There's a pair, and then let's just draw the other sides. Ooh, that one wasn't very good. Let's pretend like that actually, thicken that up, pretend like that actually matches. So there's a parallelogram. See if I can thicken that up a little bit, make it all a little bit more consistent. There you go. That's a better looking parallelogram. But then there's a special type of parallel, or probably not parallelogram, trapezoid. A special type of trapezoid is a trapezoid whose non-parallel sides are also congruent. So again, we have parallel sides. But now these sides, these other sides that aren't parallel, these right here, I'll draw them red just to indicate them. These sides, if these are congruent, then that's an isosceles trapezoid. Okay, so lots of stuff right there. Alright, lots of stuff for you to just write that down. You don't have to have it memorized, just write it down, because when we go through stuff, you're going to have to know how to do all those things. Alright, so let's keep moving on. So here we go. So here's all the things we just talked about. Okay, now they're all related. Okay, they all live in this world that we call quadrilaterals. I'm going to put that right there. And so now a parallelogram, okay, that's kind of a special one. So I'm going to put this over here. So a parallelogram, okay, if you can imagine, is a special type of quadrilateral. All right, well, what else is a parallelogram? Well, a rectangle is a parallelogram. I'll put this over here. So a rectangle, so by this, if you look at it, that means a rectangle is a parallelogram, which is a quadrilateral. So a rectangle is a quadrilateral. Okay, what else? Well, if you remember, we have a little thing called a rhombus. A rhombus is another one. Okay, that is a parallelogram. Remember, that's the one where opposite sides are parallel and all sides are congruent. And do we have any other parallelograms? Sure, we have one more. Okay, and that's the square. So where do squares go? Well, squares go down here. Okay, because a square is not only a quadrilateral, not only a parallelogram, but it's also a rectangle. Because remember, rectangles are parallelograms with right angles. Well, all squares have right angles. Also, a square is a rhombus. Why? Because squares have sides that are not only parallel, but they are congruent. And a rhombus has probably all sides congruent. Okay, so if we think about this, okay, so a quadrilateral, okay, parallelograms are always quadrilaterals. Rectangles are always parallelograms, which are always quadrilaterals also. A rhombus is always a parallelogram, which is quadrilateral. And a square is also a rectangle. It's a special type of rectangle, special type of parallelogram, and a special type of quadrilateral. Or you can go the other way. A square is a special type of rhombus, okay, etc. Now what about these other two things? Well, they're both quadrilaterals, but they kind of live in this other little world over here. Okay, so a kite, while it's a quadrilateral, it's kind of over here by itself. And trapezoid, same thing. It's not a kite, okay, so we wouldn't put it underneath that, but it is a quadrilateral. Okay, so all trapezoids are quadrilaterals, but not all quadrilaterals are trapezoids, and vice versa for kites and parallelograms, etc. Alright, let's keep moving. Alright, so here's a couple theorems. Again, probably a good idea to hit pause and just and start writing these down. Now these are just some special ideas here behind parallelograms. Parallelograms are pretty important. Okay, and so if I take a look at a parallelogram, let me just draw one here for a second. Okay, forgive the freehand. Okay, parallelogram, opposite sides are parallel. That's all the definition says. Okay. But now we have these theorems. First theorem says opposite sides of a parallelogram are congruent. So that means always. Anytime I have a parallelogram, opposite sides, so this side would be congruent to this side, and this side would be congruent to this side. Always. Okay, so you can write that down. Okay, what else does it say? Well, it says opposite angles of a parallelogram are congruent. So that would mean they're talking about this angle and this angle are congruent. Or this angle and this angle are congruent. Doesn't mean all four of them are congruent. It just means that this one and this one, so opposite, or this one and this one, or opposite, are always congruent. Alright, last one says diagonals of a parallelogram bisect each other. Well, this one's getting a little messy, so let me move it over here for a second. Alright, let me draw a little bit smaller. So let me draw another parallelogram. Say I have another parallelogram right here. This time it's saying if I have diagonals, so a diagonal would look something like this. Another diagonal that looks something like that. What this is saying is diagonals of a parallelogram bisect each other. So that means if I call, let's give all these vertices names. So AC splits DB in half. Okay, so this portion right here is the same as this portion. Okay, and the same thing goes the other way, is that DB splits AC in half. Okay, so pretty helpful right there. Alright, so let's keep moving then. Alright, another theorem. Okay, not the most valuable one in the world, but it simply says if three or more lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. So first question is, what's a transversal? Well, a transversal is a line that cuts into others. So for instance, this would be a transversal. Okay, and this definition says that if three or more lines cut off congruent segments on one transversal, meaning that if we call this, that little part A, B, C, so meaning this point. So what this is saying is if I have these lines right here that are equally spaced out so that it makes this congruent to this, then if I were to draw any other transversal, say let's say this one or this one, then what that is saying is that it'll cut this one equally, it'll cut this one equally, etc., etc. Okay, and that's it. Alright, here's some more. Alright, so again, probably a good idea to even go ahead and hit pause and write some of these down. Okay, we're pretty heavy on theorems early on in the first couple lessons that we do. So let's look at the first one. It says if both pairs of opposite sides of a quadrilateral are congruent, then it's a parallelogram. Okay, so this is saying, well, what if I don't know it's a parallelogram? What if I just know that it is a quadrilateral and that opposite sides are congruent? Alright, so meaning, say I have four sides. And the only thing I know is that this is congruent to this and this is congruent to this. Then by that first theorem is saying, well, if you know that, if opposite sides are congruent, then what that is saying is that you can then assume that it's a parallelogram. And if it's a parallelogram, what can you then say? Well, you can say that this is parallel to this is parallel to this. Okay, so that's handy. If you're looking at something and you see it and you're saying, oh, well, opposite sides are congruent. I don't know that they're parallel, but by this theorem says, as soon as you know opposite sides are congruent, then you can assume that they are parallel. Alright, so let's talk about the next one then. I'm going to move this over a little bit here. Next one says, if both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. So again, if I draw parallelogram, okay, and this one is saying if opposite angles are congruent, so it means if I know this is congruent to this and that this is congruent to this, then I can say, oh, well, that's a parallelogram. So therefore I can make this assumption. Just like that. Next one. If diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So meaning, So I'll draw it again. This time. And as soon as I know that this is being bisected and this is being bisected, so in other words, A, B, C, D. So AC bisects DB and DB bisects AC, then I can automatically say, oh, well, then that has to be a parallelogram as well. Okay, and then last but not least, the last theorem says if one pair of opposite sides of a quadrilateral is both congruent and parallel, okay, then it's a parallelogram. So, meaning, so if I have one pair, so let's just say this pair right here, it's congruent and it's parallel. If I just know that, then this theorem says, all right, well, if you know that, that's good enough for us. Then you can also assume that this is parallel as well. Okay, handy stuff right there. Okay. All right, let's keep going on here. All right, so a couple other ideas here. These are both involving rhombus. All right, so each diagonal of a rhombus bisects two angles of the rhombus. So let's think back. What's a rhombus? Well, rhombus is a parallelogram, but it's a special one. It's one where all the sides are exactly the same. And this is saying, though, so a rhombus could be a square, okay, but I'm not drawing it as a square here. It says each diagonal of a rhombus bisects two angles of the rhombus. So in other words, if I have a diagonal here and from here, that means it splits. So in other words, this angle is the same as this angle, and that this angle is the same as this angle. And I can do the other way around too, if I were to draw it this way. That just means that this splits it, okay, and splits this one. Ooh, lots of lines there. So basically it just says the diagonals of a rhombus split the angles, okay, of it. All right, and then it also says here this other theorem, this second theorem right here, says the diagonals of a rhombus are perpendicular. So if I were to go through, let me fill, I don't know why I draw this dotted. Let me fill that in. So what this is saying is it's perpendicular, meaning that it creates a right angle right there. So if I were to draw that one more time, maybe a little bit better. If I were to draw in some diagonals, that this theorem is saying that that creates a right angle right there in the middle. All right, last but not least here on this page, okay, we got one more page. It says diagonals of a rectangle are congruent. So in other words, a rectangle, we all know what a rectangle is. We've seen it a million times. And this is saying, and hopefully this makes some sense here, that the diagonal, so this diagonal from here to here, is the same length as this diagonal right there. So if I were labeling this A, B, C, D, AD would be equal to BC is what that's saying. So this length is the same as this length. All right, last one. Okay, so these involve trapezoids. All right, so the base angles of an isosceles trapezoid are congruent. All right, so let me draw an isosceles trapezoid. So, oops. So we have two parallel. These sides are congruent. Okay, remember congruent. Parallel. So this is saying the base angle. So this angle is congruent to this angle. Okay, the next theorem says the diagonals of an isosceles trapezoid are congruent. So in other words, this diagonal is the same as this diagonal. So again, if I were to label A, B, C, D, then it's saying AC is equal to BD. All right, last but not least, all right, I'm sure you're hoping for this to be done here. So it says a kite. Let's go kite. Remember, adjacent sides congruent. So this is saying the diagonals, this diagonal, this diagonal, create perpendicular. All right, and that's about it. Okay, that's about it for this section. So we will apply that when we get to class.